Good morning to everyone. In today's session, start with the discussion of the importance of SQL, what exactly the SQL is, importance of any specific database, what exactly the database is, how the information is stored. That kind of discussion we would be continuing. And at the end, if time persists, we would see few database or storage options which we, as a data analyst, come across in our any project or in which we come across in our any job related roles, so that we are going to discuss. See, I'll ask you one question. How many of you, if you are any food items which are left out, how many of you use your fridge? Almost everyone. When if you want to keep that food item, if you want to keep any specific product or food product which we may not consume on the daily basis, but we have to keep it in the fridge, we try to arrange it or we try to sort it accordingly. Now, similarly, you can take any specific, it might be a fruit product, it might be any product which you want to arrange in a specific order, which, the next time when you are searching for that product, it would be easily available. Now, that easy availability is nothing but because you are arranging it in a certain order. Now, similarly, for any data analyst, if a data is coming in any unmannered order, it is the role of a data analyst to arrange any specific information. If you arrange that specific information, you're trying to get that product whenever you're searching it very easily. Similarly, database is also one of the same concept where all the information is correctly sorted. In case of database, how do you interact with that database? There are multiple options available. The agenda of today's session is why do we need a database? What all schemas are available in a database? What all different types of databases are present. Now, why and what is SQL? Database is there, but what is SQL? What is SQL with respect to database? The exact history, ways of processing the database, and maybe if time persists, as I've said, we'll see a few more databases available and installation for specific database. Now, if I move ahead, see, can anyone read this? I guess except this word, no one would be able to read it. Why? Because this language is unknown to us. This specific language is unknown to us. Now, if I take the second information, this is very easy to understand. Why? Because we already know the English. SQL is nothing but the way of interaction, how to communicate with any specific database. Database is nothing but where information is stored, accepted. But how do you interact with that database? How do you make sure you're trying to communicate with that database? That communication is called as SQL. Now, how do you communicate? With the help of SQL. SQL is nothing but a programming language. It's a kind of programming language. It's a kind of database programming language, which will help us to interact with the database where the information is kept. Now, the same information you can read in this way also. The first one is English, the second one is Hindi. Why? Because we both know, both the languages are known to us, or everyone knows both the languages easily. That is the reason we are able to understand it. Similarly, for any kind of database, if you want to interact with it, SQL is the best way to communicate. So if you ever come across SQL, do not worry about it. SQL is nothing but a language. It is just like your English. It is just like your mother tongue. If you want to communicate with some other individual, you will use your mother tongue or you'll use a common language between both of the individuals. Similarly, if you want to connect with the SQL, if you want to interact with the database, you have to use this language. And SQL is a very, very easy language. If you know your language basics, you can easily learn SQL. So moving ahead, how is SQL, how SQL different it is, what is database, we are going to. Why do we need a structured information? In order to directly jump to the database, we need to first understand why do we need a structured information. Now, what exactly the structured information is? See, if you visit any specific, or you are trying to read any specific dictionary, in dictionary, there is an option called as index. As per index, as per alphabetical order only, every information is correctly sorted. Now, this is one example. If you visit any book which doesn't has any index, where the information is not correctly sorted, it is very difficult for us to understand. It is very difficult for us to read that book. But almost every book in the world which is available always comes with a certain set of instructions where the information is correctly ordered. The information is ordered managedly. Now, that is why dictionary, if there is a alphabetical order of information only, an individual would be very easier to understand the information, very easier to go and directly search a word which is looking out for. So structured information will help us to solve any specific problem very precisely. Dictionary is one example. Nowadays, many people are not using dictionaries. They're directly jumping to the website. They're directly jumping to the internet and they're trying to search any specific information. Now, even if you take an example of internet, this is Wikipedia page. See, even for a Wikipedia page, forget about this content. If this content is not available, the content which is towards left and the content which is available in this box, only this content is available. For an individual, the very first time if we come across this content, 90 or 95% of the people do not read this. Even though he's trying to open Wikipedia, even though he's trying to open any specific website where information is kept. Now, this is information related to data analysis. If you directly come across this and you're trying to read this, it is very difficult to understand. If you have the box option here, see, all the dimensions are mentioned here. All the important points are mentioned here towards left, towards right. And all the important points or the content of this Wikipedia page is available towards left. Now, this content plays an important role. Similarly, for any information which you want to store in database, it has to be correctly ordered. In a website, in a dictionary, you can take any example, any day-to-day life example where the information is correctly sorted. Only then it is very easy to get that information, to extract that information. Now, if the data is not correctly ordered, any random data is there, it is not correctly ordered, it is the role of a data analyst to get that unstructured data, clean that data, filter that data, or transform that data and load it in a precise or structured manner. So similarly, if you want to load any specific data to a database, it has to be in a structured manner. Now, that is the importance of structured information. Now, you might get bored that why structured information is important, how come a database, how database stores that information. See, prior jumping to any specific topic, you have to go back, check the background, what is the importance of that exact database, what is the importance of exact SQL, get the background information precisely, and only then jump into the database usefulness or database use case. Now, structured information is there. Let's understand what do you mean by database. See, in simple terms, data is nothing but, database is nothing but a storage system. It is simple storage system. How information is stored in a database? It is stored in a table manner. Assume that this is a table. The information is stored in a table manner. In every table, whatever tables we are trying to create in a database, a certain information is kept in that table. But to jump to the table, first understand what you mean by database. See, database can store large number of records. Now, as and now, data is the new fuel of this world. Wherever you go, data is increasing. And most of the data is unorganized data. Now, that is the reason we have seen the importance of structured information. If the information is not structured, it is unstructured, it is unorganized, it is very difficult to understand from any individual point of perspective. So that is the reason for us, most of the data is unorganized. In order to make that data organized, in order to make that data very precise, you have to use a database. It is the role of the data analyst. He has to go back. He has to make sure that the information is correctly updated and the information is correctly structured or organized. So in order to make any specific information in an organized manner, we can use a database. Database can store large number of records, accepted. You can interact with the database using your internet. It is very quick and easy to find information. Now, it depends on what kind of database you're using, whether the database handles a bulk amount of data or not. It is up to us. So there are multiple databases available, but in simple terms, it is very quick. Database information is very quick and it is easy to find. Now, take an example of you have a bundle of sheets. You have around 1 lakh records, or maybe you are given a set of 1 lakh records and you have been asked to find a certain set of information from that 1 lakh records. So this 1 lakh records are given in a bundle of information. Bundle means pages. Physical pages are given to you. So if you want to find any specific information with the help of around, you might have around 100 pages. Assume that you might have around 100 pages, and within this 100 pages, you want to find around 4 to 5 different records which are given to you. So from an individual point of perspective, it is very difficult to go back and search all these 100 pages. It is very difficult. And I'm not saying you cannot find it, but it will take some time. It will consume some time. Whereas this 1 lakh information is kept in any database, which is connected to internet, which can be interfaced using web. It is very quick and easy to find. Why? Because every information has a certain column and maybe a certain value present to it. If you simply search that value, it would be displayed in the database. Wherever it is present in the database, it would be displayed to us. So that is one benefit. If you're using any physical information, very difficult to find, but if you store it in a database, very easy to find and understand. Easy to add. See, if the information is easy to find, you can also easily add it. You can easily edit that information wherever you feel the information is not correctly updated. If the information is not even correctly updated, you can either delete that information also. You can edit, delete, or else you can add a new information. Now, these three activities can be done in the database. Whereas if you want to edit information in any specific printed pages, either you have to delete or either you have to cancel that information and print it again on a new page. Now, that is one drawback of using offline information or offline, any offline concept. If at all it's a database, it's very easy to understand. You can easily edit it, and that edited information or the previous information is simply updated. You can share and collaborate the data using any specific database. So there are multiple benefits. If you go on adding, there are multiple benefits of using a database. Now, once we come across a database, you need to understand what kind of language we have to use. That language is called as SQL. In order to interact with any specific database, that language is called as SQL. Now, we would be understanding the concepts of SQL in further sessions, as well as maybe if we have, if there time persists, I'll also show you how to install any specific database and how to interact with that database. What is the storage method which is used in a database? Accepted, you can store information in a database, but how that information is stored? As I've said, information is stored in a table format. That specific information is always stored in a table format. I mean, you can directly create a database and you cannot randomly dump any specific information. Why? Because information has to be in a organized manner, in a structured manner. Only then it is very easy to fetch that information. Very easy to fetch, very easy to edit, very easy to delete, very easy to add as well. What is the table structure? In every table structure, the information is either kept in rows or either kept in columns. Now, what do you mean by rows and columns? See, information which flows from left to right. Information which flows from left to right, or information which flows from from horizontal way is called as a row. Left to right, this is left, this is right, which is called as horizontal information. The information is flowing horizontally. That specific information is called as row. And if the information is kept from top to bottom, that is vertically, it is called as column. It is called as column. This is column and this is row. So any table which is created in a database has two entities. Always make sure you always have two entities. One is row, one is column. If you have row and column, it is very easy to store that information in a specific table, in a storage, or maybe in a database. Now, row is also called as a record. Column is called as a field. A vertical entity is called as a field, and horizontal entity is called as a record. There are different names, as I've said. For our point of view, as I've said, database is very easy to understand. SQL is nothing but your language. You can assume it as an English language. So if you're interacting with a database, if you're interacting with the information stored in the database, you can always use your English terminologies. So row is nothing but which flows from left to right. Column is nothing but which flows from top to bottom, vertical and horizontal information. So this is how the information is stored in any specific database. And in order to interact with this, you have to use a language, which is nothing but your English language, which is nothing but your SQL language. SQL is almost similar like English. If you know the grammatical concepts of English, it is very easy to understand SQL. Now, this is how the information is there. This is complete table. This complete information is called as table. Whatever information is flowing from left to right, this left to right information is called as row. And whatever information is flowing from top to bottom, this information is called as column. So this information is called as column. And every information is in a database is always stored as a table manner only. Database is a structured entity, is a structured storage system. The information has to be stored in a table in terms of rows, in terms of columns. Now I'll take a pause here. If anyone has a question, why only table is required, or maybe why only rows and records, or maybe rows and columns are required. You might also have a question, why only table? There are a few other databases where table is not mentioned, where table is not compulsion, but still you can, if you're using a database, it has to be a table only. Database is a structured information. There are many other storage systems where the information is not structured. Apart from database, there are many other storage systems, but in terms of database, it has to be a structured information. It has to be a table. It has to be a row and column. Okay, if there are no questions, let's move to the next topic. Now, what do you mean by schema? Now, do not read all this information. It might be very bulky. Why to read all this stuff? But in simple terms, what do you mean by schema? So let's take an example. Let's take a real-time example. If someone is constructing a new house, you're constructing a new house, or maybe you're constructing a new building structure. So in order to, construct a new structure, you need to have a good foundation. Only then the structure of that building would be very strong. If the foundation is strong, only then the structure of a building is strong. So in terms of database also, wherever you are creating any specific table, prior to creating a table, you need to create a database. So prior to creating a database, you need to have a foundation of that database. Foundation of a database should be very strong. Now that foundation is called as schema. Schema is nothing but a foundation of any database. Foundation of any specific database is called as a schema. Now, if the foundation is strong, only then the database is strong, only then the table structures would be strong. So in simple terms, database schema is the skeleton structure. Foundation is what? You have certain beams and columns. You have certain, in terms of construction, you have a certain underground structure where the foundation is very strong, where the foundation is very rigid. So similarly, in terms of database, skeleton of that database has to be very, very strong. Only then that database would survive. Only then, if the skeleton of the database, if the schema of the database is very strong, only then that database would survive. So whatever is kept in that skeleton, whatever is created or whatever is defined in that skeleton, it has to be very precisely defined. Only then the database will work properly. So in simple terms, schema, whenever you come across schema word, you'll come across this schema word almost every day if you're working as a data analyst. So if you come across schema, make sure you're remembering only one word, which is skeleton or which is foundation. If it's a foundation, the foundation has to be very strong. That means your skeleton structure has to be very strong. Now that skeleton structure is called as a schema. So basically, there are two different schemas in a database. In every database, there are two different schemas. One is physical schema, one is logical schema. Now, what do you mean by physical schema? What do you mean by logical schema? See, logical schema is which we use on daily basis. It defines the tables, it defines views, integrity constraints, whatever options are available from a storage point of perspective, all that options are derived with the logical database schema. Physical database schema, we may not come across on daily basis, but whenever you create a schema, physically, that means in real time, how the information has to be stored, the that specific whatever database you're using, depending on that API, depending on that structure of that database, physically where that information should be kept, the database will physically, it will handle it without any manual intervention. So physical database, you cannot view it. Physical database schema. This physical database schema, you cannot view it using our eyes. Whereas logical database schema, you can view it. Now, how is it possible? See, assume that there is a database called as ABC. This is the name of a database. But prior creating this database, as I've said, you need to have a very strong foundation. Now, in order to create that foundation, in order to create that schema, what do we need? We need to create a very rigid skeleton structure. Now, that rigid skeleton structure is, assume that you have created a schema called as dev schema, which is a development schema. So for this database, it is always written as dev.abc. This is the database name, this is DB name, and this is schema name. So this schema, whatever information you're trying to store in this ABC database, might be table, might be view, there are many options available. Now that options are called as logical database schema, whereas where that information is stored in the schema, that information is stored physically. That physical information is called as physical database schema. You cannot view. If you're trying to dump any information to that table, if you're trying to dump any information to that database, this ABC database, it is somewhere stored in a schema. Because schema is a skeleton, it is somewhere going back and storing it in the schema. That physical information of storing is called as physical database schema, and you cannot view it. Whenever you create a table, you can view that table in a database. So logical database schema, you can view it using your eyes. If you query any specific information, you can easily view it. Now that is called as logical database schema, and the information which cannot be viewed is called as physical database schema. So on a simple note, schema is nothing but your skeleton or foundation. There are two types of foundations. One is physical foundation, one is logical foundation. Logical foundation, we can view it whenever we query information. Physical foundation, we cannot view it. Why? Because it is the role of the database. It will automatically go back without any manual intervention, and it will automatically take place. That physical information, where to store that information, it is up to database which you are creating. We may need not do any manual intervention there. Now, this is what the exact schema is, and for any database, schema is must. Without schema, you cannot create database. If you are default creating any database, assume that you have created a database with your own name. Now, I'm creating with my own name, Ritesh. If I'm creating this database without any schema, even though there is no schema mentioning, it will always have a schema called as DBO. DBO is the default schema available in any database. You can take any database, you can take any example of a database. If you are directly jumping and creating a database without any schema, without any foundation, still in the background, it will default create a foundation called as DBO. This DBO is nothing but your schema. Default schema is always called as DBO schema. Now, what do you mean by SQL? As I've said, SQL is a mode of communication with your database. If you want to communicate with your database, if you want to communicate with the information which is stored in a database, there has to be a language. And SQL is almost similar like English. If you know English concepts, as I've said, English, if you know precisely, you can learn SQL very easily. And there are a few benefits also. As I've said, it's a communication with database, fastest and easy. Yes, there are multiple languages which are used to communicate with database. PySpark is also one language. Python is also one language. Using Python also, you can communicate with the data. Using R is also one language. You can communicate with the database. But with all these languages which are available in today's world, Python is very high concept or maybe very booming language or booming concept or booming programming language today. But still, Python can be used to interact with the database. But if you want to interact with database very precisely, and I mean, it should be very faster. SQL is very, very fast as compared to any other language, including Python, including R, including PySpark, or any other language which is available. If you want to communicate with database, blindly go ahead with the SQL. SQL is the most widely used, very fastest language to communicate with any specific database. So it was introduced by two individuals who were part of IBM. Now, many might know the company name. It was introduced by Chamberlain and Boyce. It was around 1970s. This is the history of SQL. They both were part of IBM Computer. They were IBM computer scientists. They were working in an IBM lab in around 1970s, and they have introduced one language which can be easily communicated, and they have kept that name. Usually, SQL is nothing but, I mean, if we write SQL, this is the short form. This is not the complete long form of any communication. SQL is written in this way, SEQUEL, which is structured English query language. See here itself, the name itself is indicating it's a English query language. Now, very difficult to read all these words. That is why they have removed this E, U, E. These are vowels. One who knows English precisely, A, E, I, O, U. These are all the vowels. So they have removed that vowels E, U, E. They have only kept SQL. Short form is SQL. But in simple terms, in long form, it is SEQUL, which is Structured English Query Language. And it was developed by two IBM scientists, two IBM data scientists around 1970. Now, this is the history of SQL. Now, if I take the market comparison also, you can see there are multiple languages. Python is there, R is there, Hadoop is there. This is Spark. So if you want to communicate with any database, these are multiple languages which are available. But still 60% of the market share is with SQL. Why? Because SQL is very interactive, easy to understand. It is very, very fast as compared to any programming language. If you want to interact with database, SQL is very fast. It is very interactive. And as I've said, the name itself contains structured English query language. So we are learning English since our schooling days. That is the reason it is very easy to understand SQL also. Now we have seen the history of SQL, how it was introduced, how it was developed by which individuals, why is it called as SQL? Ideally, it is SEQUEL. So they have dropped these three vowels, E, U, E vowels. So they've only kept it to SQL, which is the simpler version or the short form of the SEQUL. In any database, information is ideally stored in two different ways, or maybe two different ways of processing the data or a database. Now, directly do not jump to this OLTP and OLAP. First, understand what do you mean by database. As we have seen, it's a storage systems. How do we interact? We interact with the SQL. But how that information can be kept in a database, we have seen we can keep it in a table. But in table manner also, there are two different ways to process that information. That two different ways to process is called as OLTP and OLAP. And these two concepts are related to data warehousing. Including database, they are related to data warehousing. In simpler terms, you as a data analyst will always come across these two options on daily basis, or these two ways of processing databases on daily basis. Now, what do you mean by OLTP? What do you mean by OLAP? I might have given some examples here. OLTP contains RDBMS, which is nothing but your relational database management system. And OLAP is nothing but your warehouse or big data. Hadoop is big data, Hive is big data, Spark is big data. These are all big data languages, or maybe these are all big data options available. In simpler terms, what do you mean by OLTP? What do you mean by OLAP is? See, assume that you take an example of banking system. You take an example of banking system. Maybe you're using your UPIs. You're trying to make a payment. You visit a shop. You purchase certain product from a shop, any shop. You can take any example. You visit a shop and you want to use your UPI system, your Google Pay, your Phone Pay, or your Paytm. You're trying to scan that QR code. Once you scan that QR code, you enter the amount. Once you enter that amount, I mean, the amount is debited from your account, but it is not credited to the person who are trying to make a payment, the person or the shopkeeper where you are trying to make a payment. So if it is not credited, he will not leave us unless that amount is credited to his account. He'll get a notification there, but it's immediately debited from your account. Now, if it is debiting from your account, that amount is getting reduced from your account and it is not added to the person who you are making a payment. That means there is a drawback in a banking system. So in case of drawback, or in case of what went wrong, information is debited, but it is not credited. So it has to be very fast. Wherever the information is getting updated frequently or very fast, that system is called as OLTP system, online transaction processing. Wherever the information is getting updated very precisely without any waiting period is called as OLTP system. And the best example is your banking system, your UPI system. You try to make any NEFT transfer, you try to make any RTGS transfer also. If it is debited from your account, it has to be credited to the person whom you are trying to make a payment. Only then the transaction is called as successful transaction. So that successful transaction is nothing but your online transactional processing. Now we have seen OLTP. What do you mean by OLAP? See, OLAP is nothing but your a very vast data, very big data. Now the best example of OLAP is, so you use food, booking apps, or maybe your Zomato, your Swiggy, there are multiple booking apps. You want to, you're using your Blinkit, you're using your any big basket. So these apps will always send a notification. Now, on what basis they send a notification? They try to go back and search your previous history, that you are trying to purchase so-and-so product on so-and-so date. So that is how the OLAP plays an important role. So OLAP is nothing but your online analytical processing. Now, what do you mean by analytical processing? In simple terms, whatever information is your history information, whatever history information is there, they're trying to analyze that historical information. With that historical information, they're trying to give you some notification, they're trying to give you some offers. Now that offers are called as OLAP, that offers are called as analytical processing. So in simpler terms, information updating frequently and it is changing very fast is called as OLTP. Wherever the information is stored in the background, with that historical information, you are suggesting some updates, you are giving some updates, that is called as online analytical processing. OLTP, OLAP. Two ways of processing the database, two ways of processing the information in a database. Yes, Priyanka, you have a question.
Sir, in banking like UPI also, as you said, in there also we can see that our transaction history data is already stored now. So
Hmm.
I'm a little bit confused. Like in warehouse as already information is stored that what we have ordered in the last months.
Okay.
So
Okay.
in UPI also there is like what transaction we did in last 2 days or
Very good. Valid
so.
question.
Yes, sir.
Uh, yep, I'll explain it. See, your information, your transaction information is stored, but that transaction information, the ideal mode of payment is what? You're trying to make a payment. That means you're trying to send some amount to the another person, the person who you are trying to make a payment. It has to reflect very precisely within few seconds to that individual. Only then that payment is successful. But if your transaction history is kept in the background, your historical information, assume you take an example of passbook. So OLAP is nothing but your passbook. Passbook is only used to check the information, but it is not used. OLTP is very precise. It is updated very frequently. OLAP is not updated frequently. It is your historical, it is your background information. So in simple terms, whichever information is kept idle is OLAP. Whichever information is updated frequently is called as OLTP.
Yes, sir. Thank you.
Yeah, many might have also a question what exactly OLTP, OLAP is again. If you have a question, feel free to ask. So I'll take a pause of 1 minute here. If you have a question, feel free to ask any random question also.
Sir, now for UPI, as you said, so we can take example for both also, like for
Yep.
OLTP and OLAP.
Yes, definitely.
Ritesh?
Okay, go ahead.
Yeah. So just I need to understand. So how do this OLAP and OLTP will complement each other?
If you repeat your question, I guess it's very low. Your voice is very low. If you can repeat it.
So now you're audible, right?
Yes, you're audible.
Yeah, yeah. So how do this OLAP and OLTP complement each other?
Okay, let's take, as we are discussing UPI only, let's take an example of UPI. Whenever you open an account, with opening account, any bank will never offer a credit card to you. Credit card, a bank is offering a credit card depending on your transaction history, depending what amount of money you are keeping in that account. Now, with the help of UPI, they can always offer you a debit card. And debit card is what? Best example is your debit card and credit card. In case of debit card, it is offered on the very first day. Why? Because debit card is must in order to make any UPI transactions, in order to remove, in order to encash any amount from the ATM, debit card is must. So if you use your debit card, you can either encash your money from the ATM, or else you can make an immediate payment using UPI. So wherever there is an immediate payment, it is directly updating on frequent basis. Whereas if a bank is offering you a credit card, how they offer? They go back and check your transaction history. You are doing so and so transactions. You are using UPI on the grocery payments. You are using UPI on any other payments. You maybe or online. If you are booking some online, you're trying to book or you're trying to purchase, you're trying to order any product from online systems, maybe Amazon or Flipkart. So depending on your transaction history, they try to go back and analyze which card is best for you, which credit card is best fit for you. Only then the bank will give you a suggestion that with your transaction history, we are trying to offer you a credit card with so and so benefits. And how do they offer? They go back and check your transaction history. The transaction history is nothing but your analytical history. So this is how the OLTP and OLAP go hand in hand. I'm not saying both are similar. I'm not saying both will always go hand in hand, but OLTP and OLAP are somewhere interdependent on each other. Whatever OLTP you do, after some days it will become OLAP, it will become history. Now, depending on that history, bank will suggest you which card is best fit for you. Which card is best. If you're trying to purchase or if you're trying to order products on frequently on any website, they'll offer you an Amazon credit card. They'll offer you a Flipkart credit card. There are multiple cards. So that is how the OLTP and OLAP go hand in hand.
Yeah, understood with this. Thank you.
So take one, make one thing in mind or keep one thing in mind. If you are using OLTP, after 2 days, it will go back that whatever OLTP information is done, it will be stored in the OLAP system. It's a historical data. So historical data is nothing but your OLAP system. And why big data is always called as, or why data warehouse is always called as historical data or maybe OLAP is because big data will have a large chunk of data. Now, this is the example of OLTP, as I've said. An online transactional processing. If a person is trying to make a payment, this is how the payment goes. After successful, the information has to be correctly updated. Only then it is called as OLTP. Why? Because at real time, the execution of information, the change of information happens. In case of OLTP, these are the multiple examples. If you try to purchase a ticket, you're trying to make a payment, only when that ticketing website will receive your payment, the transaction is successful. So it has to be very fast. If you try to use your debit card, you try to encash your money from you try to, visiting any ATM, you're trying to encash that money, that amount which you have removed from your account, it would be updated very, very fast. In case of online shopping, also you try to order any product, only when that online shopping website receives a payment, that product, placing that product or that order transaction is successful. These are all the OLTP examples, and OLTP is one of the frequently used processing, or maybe frequently used way of processing in any specific storage system. Now, if you take an example of OLAP, there are multiple examples of OLAP. Wherever you have OLTP, you will always have OLAP also. Why? Because OLTP transactions after a few days will become history. That history transactions are nothing but your OLAP transactions. Now, what is the exact difference between OLTP and OLAP? See, it is characterized by a large number of short online transactions. So if a person is using a debit card, if a person is using a UPI, for every UPI transaction you make, all the UPI transactions are short transactions, but they are characterized by large number of transactions. Whereas OLAP, it is characterized by large volume of data. Volume of data is very large in case of big data, in case of online, in case of your historical system. So you can have your banking statement printed for last 10 years also. So that is how the large volume of data is in OLAP. And OLTP always uses your traditional DBMS, which is nothing but your database management system. Whereas OLAP always uses data warehouse. Now, we will discuss what do you mean by DBMS. We will discuss what do you mean by data warehouse. But prior jumping to that, first understand where do we use this OLTP and where do we use this OLAP. SQL is nothing but your OLTP. SQL is nothing but your OLTP. Why? Because if you're using a SQL, it is very, very fast. And most of the OLTP transactions uses SQL. If at all that information is updated, which is a historical information, and you want to interact with that OLAP historical information, that in that case, you can use PySpark, you can use Python, or you can use any other programming language, any big data programming language like Hadoop. Hadoop can be used, Hive can be used. Even SQL can be used to interact with the data warehouse. Even that is possible. But very rare chance. Most of the OLTP uses SQL. Most of the OLAP uses big data languages. Now, there is also a SQL and NoSQL. What do you mean by NoSQL? NoSQL is neither OLAP, NoSQL is neither RDBMS. RDBMS is nothing but your relational database management system. Now, what do you mean by relational database management system? Let me show you. See, in simpler terms, RDBMS is nothing but your relational database. Now, what do you mean by relational databases? The one who have attended yesterday's session, I might have explained the example of banking. Now, why am I using banking example on frequent basis? Is because this example is very easy to grasp. And this we use on frequent basis also. I mean, as an individual, almost everyone in India is now using a UPI. So best example is any banking system. There are multiple systems or there are multiple domains which uses RDBMS. So in case of RDBMS, if you are opening a bank account, bank will have a fact table, which is the centralized table. One fact table is further connected to multiple dimension table. So assume that your information is kept here, your primary information is somewhere connected to multiple dimensions. This is one dimension. This is one dimension. Now, what do you mean by dimension? If you're opening a bank account, you will have a unique customer ID, which is kept in this fact table. That customer ID is connected to a transaction table where all your transaction history is kept. That customer ID is connected to your personal information table where all your personal information is kept. That customer ID is connected to a table which is cards table. How many cards you have, what kind of cards you have, either you have a credit card, either you have a debit card. That fact table where your customer ID is kept, it's connected to one more dimension where all your NEFT, where all your RTGS information is kept, where all your beneficiary names are added. So multiple dimensions are surrounded by a single fact table. And how they are connected? They are connected using certain similar column. That similar column is called as a relational column. There is a relation between fact table and dimension table. There is a relation between this fact table and this dimension. There is a relationship between the central fact table and this dimension. So every dimension is connected to this fact. That connection is called as a relation. There is a relation between every table which is connected here. Somewhere this dimension is also connected to this dimension, but it is connected via fact table, this centralized fact table. So if you take an example of database is always a RDBMS, which is nothing but a relational database manager. In case SQL is a RDBMS, there is also a concept called as NoSQL. There is no RDBMS in that. You can store structured as well as semi-structured data. It is not always a structured data in NoSQL. Now, few of the examples of NoSQL are MongoDB, Cassandra, Amazon DynamoDB. There is an database which is also called as Cosmos. Cosmos is also NoSQL database which is present in Azure. From our Microsoft point of view, there is also a database called as Cosmos. This Cosmos is nothing but your NoSQL database. And NoSQL databases are rarely used. I'm not saying they are not at all used, but they are rarely used. One of the biggest disadvantages, it is very difficult to find any information in this NoSQL. Why? Because there is no relationship between all the tables which are present. If there is a relationship between the tables, it is very easy to fetch. Why? Because information is correctly stored in the tables. Whereas in NoSQL, there is no table, there is no relation, there is no structure. Sometimes the information is semi-structured, but only semi-structured information is not enough. It has to be stored in a table. It has to be correctly declared. So NoSQL is also a kind of database, but it is rarely used. And there are few NoSQL databases also. If you compare it with NoSQL database, MongoDB is one of the widely used NoSQL. But it is only with respect to NoSQL. As I've said, 90% of the time world uses SQL and 10% of the time world is using NoSQL. There are very few chances you will come across as a data analyst you use this NoSQL database. In simpler way, if I try to explain it, what do you mean by DBMS? DBMS is nothing but your database management system. How do you manage data in a database? We have seen we can store information in a database in a table. We have seen how can you process that information either using OLTP or OLAP, but how that information is kept in a database. That information is kept in 3 different architectures. Now that architectures are called as database management system. How do you manage a database? How do you make sure the database is correctly managed? How do you make sure the database is correctly updated? In that case, there are 3 different architectures. One is 1 tier, one is 2 tier, and one is 3 tier architecture. And these 2 architectures are historical. They are not used nowadays. I mean, 1 tier is not at all used. It is, the history. 2 tier, if you go back to minus 10 years, still 2 tier architecture was used. But since last 10, 12 years, even this architecture is not at all used. Nowadays, 3 tier architecture is used. This is most widely used. And you need not bother about 1 tier and 2 tier. So this is your 3 tier architecture. This is your 3 tier architecture. Now, what do you mean by 3 tier architecture? This is tier 1. Tier 1 layer. This is layer 2 and this is layer 3. Now let's take the same example of your UPI, your banking system. You as a client trying to make a payment. Now where do you make a payment? You try to make a payment where you're purchasing something. You're purchasing a product. Now while making a payment, it will go back and fetch, it will try to connect with a server, certain server. Once you connect to the server, only then the payment transaction will happen. Now, in order to connect with the server, there is an interactivity between client and server. This client server architecture is called as DBMS architecture or 3 tier architecture. If you are a client, you are trying to communicate with the server. How do you communicate? There is a way of communication. That way of communication is medium. This is the way of communication between client and server is called as layer 2. Layer 1 is your server. Layer 3 is your client. If you're trying to make a communication, that communication is called as a layer 2. There is some information, there is some communication between client and server. Now that client and server architecture is called as three-tier architecture. What do you mean by types of DBMS? In three-tier architecture, you can store it in 4 different DBMS, 4 different database management systems. Most widely used is your relational. 90% of the time, again, I'm trying to say 90% of the time you will use this relational database management system. 10% of the time you can use the other 3: hierarchical database, network database, and object-oriented database. And I will not stress your information more on hierarchical, more on network, more on object-oriented. But in simple terms, if I take one-liner description, in case of hierarchical information, hierarchical is nothing but your family history. Grandfather, father, you as a child, maybe your children. It is nothing but your hierarchy. Flow of hierarchy. This is how the hierarchical information is stored in a hierarchical database. There is a parent node, there is a child node, and every child node will again have multiple child nodes. So that is how the information flows in hierarchical information or the hierarchical database. Now, what do you mean by object-oriented database? See, if you take an example of object, wherever an information, Java is nothing but your object-oriented language. Java is nothing but your object-oriented language. Now, what do you mean by object-oriented database? See, if you take an example of a person, how do you describe a person? If you're trying to take an example of a person, how do you describe a person? A person has, maybe he's very tall, very lean, maybe slim. So you can describe a person with his height, with his physique, with his maybe with his language also. You can describe that person, whether from which state he is, from which country he is. So there are many ways of describing that certain individual. So in case of object-oriented database, person is an object, and these are all the behavior, or these are all the factors of an object. How that object looks like. Person is object, and you're describing that object. So description is nothing but your object-oriented database. If you're describing an object and you're describing some features of that object, that features are called as object-oriented database. Hierarchical is your parent and child node. Object-oriented is nothing but your object and features of that object. Network database, this is also very rarely used. There is a network, there is a communication between multiple nodes. This is how the network database will work. There is one network here, it is connected to this network. This network is somewhere connected to this. This network is somewhere connected to this. This is somewhere again connected to this. So do not go in depth of network, do not go in depth of hierarchical, do not go in depth of object oriented. 90% of the time, or almost as a data analyst, every time we would be using relational database. And relational database, as I've said, there is one central table which is further connected to multiple dimension table. That is nothing but your relational database management system. This is how the relational database management system look alike. Now, SQL is nothing but your relational database management systems. And these are all the SQL databases which are available in current market. SQL Server, it's a cloud-based database. PostgreSQL, it is also a cloud-based database. Oracle, yes, it is also a cloud-based. IBM DB2, even this is cloud-based. MySQL, it is cloud-based as well as it is local system also. And even MariaDB, it is also a cloud-based database. Now, from our learning point of perspective, we would be starting with MySQL. I'll show you how to install MySQL Server. How do you update? How do you install it? How do you make sure the database is created? How do you make sure the schema is created? All that information we would be discussing in the further sessions. But these are all the SQL databases available, and SQL is nothing but your relational database management system, RDBMS. And at the last, As I've said, I will definitely explain you what is the difference between database, what is the difference between data lake, and what is the difference between data warehouse. See, if you're working as a data analyst, you have to understand all the scenarios. So what do you mean by database? What do you mean by data mart? What do you mean by data warehouse? And what do you mean by data lake? You need not read all this. I'll take one example, which is easier to understand. Assume that there is a certain product which is getting manufactured. Now, how a product is manufactured? Either it is manufactured in a factory where all the raw materials are kept. Now, wherever the raw materials are kept, wherever it is manufactured, that manufacturing unit is called as data lake. Take an example of factory. Factory is nothing but where all the raw materials are kept, and with the help of that raw materials, see raw, with the help of that raw materials, that finished product is manufactured. Once the product is manufactured, it comes to certain data warehouse. It comes to certain godown where that product is kept. So take an example of any food product. Take an example of masala only. Your day-to-day masalas, your day-to-day herbs. If you're using masala, a masala is manufactured using multiple raw material. So multiple raw materials have combined together. It is manufactured in a factory. Once that masala is packed, it comes to certain godown. So that godown is nothing but your data warehouse. In that godown, every product is segregated. Segregation of information is very, very important. Every product is segregated in different racks. So in a godown, in a food godown, there are multiple different segregated racks. So in simple terms, all the masalas are kept in one single rack. All the packed products, maybe you take an example of any packed product, maybe your dairy products. All the dairy products are kept in a single rack. All the masalas are kept in a single rack. All your loose food products, um, you can take an example of your any dal. You can take an example of any seeds which you are utilizing on daily basis. They are all kept in a single rack. So that single racks are called as data marts. Data mart is nothing but a similar set of information which is stored in a data warehouse is called as data mart. So whenever a product is manufactured from a factory, that factory is your data lake. Once the product is manufactured, it comes down to a godown. Godown is nothing but your data warehouse. And in a godown, all that information is kept in individual racks. That individual racks are called as data mart. And the database is nothing but a single product which is sold in a market. Database is nothing but a single product which is sold in a market. So in simpler terms, take this example as the best example. If you want to describe data lake, data warehouse, data mart, and database, any product which is manufactured, that manufacturing unit is called as data lake. Once it is manufactured, it comes down to godown. That godown is called as data warehouse. In godown, that information is segregated in separate racks. That separate rack is called as data mart, and that single product is called as database. I'll take a pause here. If you have any question with respect to data lake, data warehouse, data mart, and database, feel free to ask.
This example is not clear.
With
The example is not clear, sir. Can you
okay, the
repeat
example
once
is not clear. Accept. Okay. Remove that product. Take an example. If any certain element, I mean, if element is coming, it is manufactured somewhere. So that manufacturing unit is called as factory. That manufacturing unit is called as factory. In factory, information is available in raw manner. Now, if you take an example of a soap, a normal soap, which we use on daily basis, soap is not directly available in nature. It has to be combined. Multiple products has to be combined together. Now, what that multiple products are? Multiple products are raw material. So wherever a raw material are combined together, that is called as a factory. So in case of data lake, information is available in raw manner. It is not structured information. Data lake is always unstructured, purely unstructured. So in case of data lake, you take any example, information is not correctly structured, where all the raw materials are kept is called as data lake. Now, Whenever all the raw materials combine together to form a finished product, that finished product is stored somewhere. Now, data warehouse is always structured information. This is always a structured information. Sometimes it is called as semi-structured, but most of the time this is a structured information. Most of the times the information is structured. So once that soap, that daily soap, which is manufactured in the factory, it is coming down to go down. That go down is called as a warehouse. Every product which is manufactured, it comes to a warehouse. From that warehouse, it is segregated to different shops. So in that warehouse also, that information is kept in different racks because it is very easier to find. That different racks is called as data mart. So a raw material is your data lake. Whenever raw materials combine together to form a finished product is called your data warehouse. In data warehouse is structured. So where that structures are correctly mannered, where that structures are correctly kept are called as data mart, and that single unit is called as database. In a factory, a single soap is not manufactured. Bulk number of soaps are manufactured. So assume that there are 10 soaps. These are all the 10 soaps. So these 10 soaps are manufactured in a factory. Once they are manufactured, they are coming to a warehouse. In that warehouse, that information is correctly stored. Now, where these soaps are stored in a certain rack, if a storekeeper is coming down and trying to check where these soaps are kept in a certain rack, that certain rack is called as data mart. So data mart is nothing but similar set of information. Wherever a similar set of information is kept, that is called as data mart. And single individual soap is called as database. Individual soap is called as database. So this is simple an example. I mean, this is simple example to understand. You can take any product which is manufactured in a factory. Factory is nothing but your data lake. Because in factory, all the raw materials combine together. Once that raw materials are combined, it goes to a warehouse. It is stored in the warehouse. Warehouse is nothing but everything is structured. Why? Because product is manufactured. But in warehouse, every information is segregated separately in different racks. That single rack is called as data mart, and that single product is called as database. Does that answer? Or still, if you want any other information or maybe any other example, I can explain it again.
Yeah. So data mart is information about the data, a product in the data warehouse.
Yep, a product in a data warehouse. Similar set of products.
Okay, sir. Okay, got it. Thank you.
So in simpler terms, data lake is the highest. After data lake, data warehouse is the highest. And after data warehouse, data mart is the highest. And database is at the lowest level. So data lake is the biggest information. After data lake, second biggest is data warehouse. Third biggest is data mart. And the very smallest information is your database. Yep. Any questions on these? And all these are storage systems. All these are storage systems. In data lake also you can store. In data warehouse also you can store. In data mart also you can store. And in database also you can store. And if you see here, the explanation itself is giving you an example. Where is the primary use of data lake? It is used for analytics. Where is the primary use for data warehouse? Analytics as well as reporting. Where is the use of data mart? It is only used for reporting. Where is the exact use of database? It is used for updating the information, which is transactional information. And database is nothing but your OLTP. You can assume data warehouse and data lake as OLAP because it's a historical information. The information is already done and dusted. You cannot change it. Once the product is manufactured, either you have to dismantle it. You cannot remove all the raw materials and segregate that product. And if you see the costing here, database is very low. Why? Because it is updating frequently, need not maintain all the historical information. Whereas data mart is medium, even data warehouse is medium, but data lake is very high. Why? Because data lake handles bulk amount of data. Your all historical data can be dumped to the data lake. And if you see the design time, there is no time required to create a data lake. Why? Because you are dumping any raw material there. You can dump without any design also, you can dump any random information. These are all the features of all 4 storage systems. But to understand a storage system, always take an example of single element which is manufactured. It is coming from a factory. Factory is your lake. It comes to a warehouse. Warehouse is your data warehouse. In that warehouse, every information is segregated separately. It is stored in separate racks, separate areas. That single rack is where the similar set of information is stored is called as data mart, and that single product is called as database. And if you explain it this way in interview, interviewer will definitely understand this person knows what data lake is, what data warehouse is, what data mart is, and what database is. Okay, any other question? In simpler terms, whatever we have learned today, we might have gone through multiple slides, but in simple terms, I'll explain it. Schema is nothing but your skeleton of database. Now, what do you mean by database? Database is nothing but your storage system. It's your storage system. In order to create a storage system, you have to first create a schema. Now, once the schema is created, database is created. Now, ways of processing data. Ways of processing data. What are the 2 ways? Ways of processing data. One is OLTP, one is OLAP. Now, OLTP is nothing but your SQL, which is updating frequently. OLAP is nothing but your big data concepts. Anything related to big data is all your OLTP. So once this is done, there are 3 levels, or maybe 3, let's keep it to only 1, 3-tier architecture. Forget about 1 tier and 2 tier, 3-tier architecture. If the information is stored in database, it has also be, information has to be also be managed. Managing the information is also must. If you go to any specific, if you take an example, you take an example of any coaching institute also. Coaching institute is also correctly managed by certain set of people. There is a head, there is the owner of that coaching institute who is managing multiple other individuals, and every individual again is further connected to multiple other individuals. Maybe if you take an example of KSR itself, Mahesh is the one who is central, who is managing all this KSR institute, and we as an trainers, we are managing every batch separately. So in case of database also, it has to be the information which is stored in database, it has also to be managed. It is the right of that individual to manage that database. So that managing database is called as 3-tier architecture. Now that 3-tier architecture is called as client and server architecture. In order to connect client and server, there is a medium, that interactivity medium is called as layer 2. Client is layer 1, server is layer 3. You can interchange the layer 1, layer 2, or layer 1, layer 3 also. But client and server are layer 1, layer 2, and there is an interactivity between them that is called as layer 3. That is 3-tier architecture or 3-layer architecture, which is nothing but your client server architecture. Now, once that is done, we have seen types of DBMS. How do you manage data? And forget about other 3. Only, keep in mind RDBMS, Relational Database Management System. Relational DBMS. Why? There is a relationship between multiple tables, and SQL is your relational database management system. And what do you mean by SQL? SQL is a English language to communicate with any specific database. SQL, SEQUEL, it's your storage English language. In order to communicate with database, you have to use SQL. And RDBMS is your relational database management system. And in order to interact with RDBMS, you need to have a SQL. And at last, we have seen what is the difference between data lake. Data lake is at the highest position. After data lake, it is data warehouse. After data warehouse, it is data mart. Data mart is a part and parcel of data warehouse only, and after data mart, it is database. Database is at the lowest level of hierarchy. Why? Because information is frequently updated. In all last 1 hour, this is what we have learned. Now, any questions on these concepts? Okay. If there are no questions, we are good on time. It's almost 9:25. We'll connect back on Monday. Monday, I'll show you how to install any database, how to connect that database, how to create a schema of that database. We'll discuss all that things on Monday. I'll be also sharing how to install. I mean, installation steps, installation PPT would also be shared so that there won't be any confusion while installing any specific database, which we would be using on daily basis. Okay, if yeah.
Hi, Ritesh.
Hey,
Will you be sharing the presentation that you showed
this
us today?
presentation, you're trying to say?
Yeah, yeah.
Okay, I'll share it. Maybe I'll share it with the recording itself. I'll definitely share it. I guess was it Madhuri or maybe Madhuri has a question, it seems. Yeah, Madhuri, if you have a question, go ahead.
Yeah, Ritesh, can I ask a question?
Yeah, go ahead, go ahead.
Yeah, is data mart is like OLTP or OLAP as it is reporting?
Data mart is OLTP or OLAP.
Yeah,
What do you think? Is it OLTP or is it OLAP?
I feel like it's OLTP.
Just asking your
as it,
opinion.
yeah, I feel like it's OLTP as it is reporting.
It's OLTP.
Yeah, I feel that.
See, all these three are OLAPs.
OLAP.
Okay.
Because data mart is part, I mean, data mart is part and parcel of warehouse, and warehouse is nothing but your OLAP. If there is no data warehouse, there is no data mart. If there is no data warehouse, there can be a database. Database without any data warehouse, also database can be created. Database is nothing but where the information is, I mean, frequently updating. But if the history information is stored, either it is stored in data warehouse or either it is stored in data lake. If there is no data warehouse, there is no data mart. So data mart is purely dependent on data warehouse. So it's a OLAP. These three are OLAPs. Only database
If it
is
is dependent on other, it could be OLAP, right?
not no depend. I mean, there is no. I mean, you are getting it in wrong manner. See, if there is no data warehouse, there is no data mart. Data lake is independent. Data warehouse is independent. Data mart is not independent. Data mart is dependent on data warehouse. You cannot create data mart without data warehouse. You can create data lake. You can, once you create a data lake, you can directly create a database. There is no compulsion. You need to create a data warehouse only. Once the product is manufactured, it can be directly sold outside. Even that is possible. But if there is a data warehouse, only then data mart comes into picture. And data warehouse means OLAP. That means data mart is also OLAP. Only database is OLTP.
Okay, sir. Thank you.
Any other question? Okay, cool. Then if there are no questions, Madhuri, I guess your voice is not audible. Maybe you have unmuted yourself, but your voice is not audible to me. You can type your question in the chat. Maybe I'll try to answer.
Ritesh, all the PPT and the video would be sharing in the app, right? The website.
Yep.
Okay, done. Thank you.
Hi Ritesh, I'm Chandana. So,
Hey, go ahead.
when will be the exact basic to complex queries and all will be started?
So on Monday, we would be starting with querying part only directly. I mean, installation, it will take 15 minutes or 20 minutes maximum. Then we will be starting with query. As I've said, we might have started on 9th. Yesterday was 9th. So by end of first week in June, we would be completing SQL. So assume that your complex queries would be starting by end of May. 2 weeks of complex query. First 2 weeks would be almost how a table is created, what all constraints are available in SQL, how the information can be interacted, that all concepts would be covered. And then we would be jumping to the advanced concepts like storage procedures, your the functions, all that would be coming into picture.
Okay, yes, sir. Thanks.
If there are no questions, we are good. Let's connect back on Monday. Have a very good weekend. Let's have a discussion. Let's jump into the SQL queries from starting from Monday itself. Yep. Thank you, everyone. Have a good weekend.